So Unit 6, Lesson 3 is about complex numbers, which I've been warning you all was coming. And we probably should have worked it in even with quadratics, because that's really primarily what it's going to deal with. But complex numbers, remember, is when you take the square root of a negative and it results in a complex number. And so consider the graph x squared plus 1. So remember our transformations. This would just shift your graph up 1 unit. And if we're finding its x-intercepts, well, it clearly doesn't have x-intercepts. So there's still a way to solve this equation, but you would be taking like 0 equals x squared plus 1, which means that x squared is equal to the square root, or excuse me, x squared is equal to negative 1. So x is equal to the square root of negative 1. So from this point forward, we're going to say that I is equal to the square root of negative 1, okay? Because I squared, then I squared, excuse me, if I square both sides, would equal negative 1. Okay, so be careful. There are some common mistakes involved with that we can look at. Okay, so just reducing some things down. So if we know that I squared is equal to negative 1, I cubed would be then I squared times I. So it's negative 1 times I, or negative I to the fourth would then be I squared times I squared, which would be negative 1 times negative 1, which is 1. So things to keep in mind here, and we try to use I to the fourth as much as possible because that just goes to 1. All right, so when we're simplifying examples like this where we have I to the 17th, we want to look at how many times does 4 go into 17. And so I can rewrite this as I to the 16th times I. Well, anything that is divisible by 4 just becomes 1. So this simplifies into 1 times I, which is just I. Okay, so look for as many I to the fourths as you can. I to the 27th, same, or 1/27th, same thing. How many times can I make 4 go into that? So I can rewrite this as I to the 31, because if this is to the fourth, then 31 times 4 is 124. So that means that I have I cubed left over. I cubed is the same as negative I. Any I to the fourth power is just 1. Okay, so this is 1 times negative I, which is then negative I. All right, go ahead and try this last one. Okay, so this ends up with a remainder of 2, or I squared, which is then negative 1. Another way to do this, and probably just a faster way to do this, is to divide the exponent by 4. If you get a 0.25 at the end, then your answer is just going to be I, because it's like having 1 I out of 4 left over. If you get a 0.5, your answer will be negative 1. If you get a 0.75, your answer will be negative I. And if you get a 0, your answer will be 1. All right, what I mean by that is 102 divided by 4 is equal to 250.5. This 0.5 right here tells us that there are 2 left over, or I squared, so then it is just negative 1, which is what we got. Okay, so that's kind of a shortcut. All right, standard form for complex numbers. They can all be written in the form a plus bi. And this is the real part. A is your real part, or a real number. B is the imaginary part. Okay. So for example, you can have like 7 plus 2i. Okay, remember that real numbers fit into the complex number system. So we have real numbers, and then we have complex. Okay, thinking back to Unit 1, keep in mind that real numbers then are a subset of complex numbers. So we're just expanding our number system outwards. Remember, this doesn't work both ways. And remember, everything that falls under real, you have your rational, irrational, integers, whole, and all of that filtering all the way down. So when you are simplifying answers for this section, make sure that you don't leave any negatives under your square root. Don't write no real solution. Take out the I. And there should be no powers of I in your final answer. So the BI in your final answer should not have an exponent on it in any way. Simplify that all the way down to either I, 1, -1, or -I. All right, so we're going to treat your i's just like we would like terms, right? So like you would a variable. They are a square root, so we treat them like we did with our equations or expressions with our square roots last unit. So if I have 7 plus I minus -8 plus I, I'm going to match my real terms, so 7 plus 8 minus negative, and then my imaginary term, so plus I minus 5i, again, distributing the negative. So 7 and 8 is 15, minus 4i, just my coefficient changes, just like when I am dealing with radicals. Okay, so they work pretty much the same way as that. Okay, make sure your imaginary term is second when you're doing that. When you are dealing with square roots with negatives in them, because of how square roots work, make sure that you simplify this first. So 2 minus 5i. Even if I don't have a perfect square, I need to bring that I out before I do anything else. Plus 6 plus, and this is 4 times 2i, right? And so simplifying that one step further, I have 6 plus 8i. Now I'm adding my like terms. I don't have to rewrite it every time, but make sure you know which terms are like. So 2 plus 6 is 8, and then negative 5i plus 8i is positive 3i. Okay, you can rewrite and group those together if you need to. So remember your product rule for your radicals as far as inside with inside, outside with outside. We're going to do the same thing here. But because of our negatives, if I do -4 times -8, that becomes a positive. And I've lost the fact that this is going to be a complex number. So you have to simplify this first. So square root of 3 minus 2i times 6 doesn't reduce, so square root of 6 minus, and this breaks down into 4 and 2 and the negative So I'm going to do 2i on the outside with my leftover 2 on the inside. So simplifying that first before I do anything else. Then I can just FOIL distribute this. So this is square root of 18, where this would be minus 6i root 2. Excuse me, I did that backwards. It would be minus 2i root 6, inside with inside. And then we go here, minus 2i root 6. And then we go here, so plus 4i squared root 2. So when you're simplifying expressions like this, we're going to simplify our radicals. So this is 9 and 2, 3 root 2. If they simplify, we're going to combine any like terms that we have. So minus 4i root 6. And then we need to also make sure we change any i's that have a power. So this becomes minus, because remember this is negative 1, 4 root 2. Well, now I'm not done, because by doing that, I created another like term that I need to combine. So negative root 2 minus 4i, just forgot I said it, I didn't write it, minus 4i root 6 would then be my final answer. Okay, so go ahead and try this one following your rules of radicals. Okay, so you're just going to distribute this through. All right, treat it like a variable, but then keep in mind that this I squared is equal to negative 1. And so negative 6 times negative 1 changes this to negative 15i plus 6. Rewrite this in standard form so that the I is second, please. And then that will be your final answer. All right, this one is FOIL distribution. So once again, we have 5 plus 5i, then minus 3i, and then minus 3i squared. So treat it like an x, but then replace this with a negative 1. So we get 5 plus 2i plus 3, which means this 8 plus 2i. Okay. All right, so conjugates are back. Conjugate of a plus bi is the same as conjugate with a radical. We're going to use the same two terms, but we're going to switch signs. So we're at a minus bi for our conjugate here. What happens then when we multiply by a conjugate? Go ahead and multiply those. Okay, so when we multiply, we get 25 minus 10i, then plus 10i, then minus 4i squared. Because I squared is negative 1, this changes to plus 4 as these two middle terms cancel out, and we just get a 29. So again, we're rationalizing it. And if it was on the bottom of a fraction, then we would need to rationalize that fraction because we don't want any i's in the bottom. So we multiply the top and the bottom by the conjugate of the denominator, just like we did with our square roots. Because remember, I is a square root. And so if I have 3 plus 7i over 1 minus 6i, I need to multiply that by its conjugate. So I'm going to FOIL both the top and the bottom by 1 plus 6i. And then simplify that from there. And so, again, you're just distributing. So 3 to 1, 3 to 6i, 7i to 1, 7i to 6i. Over down here, I do 1 plus 6i minus 6i, and you can kind of skip that part if you want. Then minus 36i squared. All of your I squareds then should be replaced with negative 1, and any like term should be combined. And so we end up with 3 plus 25i minus 42. over 1 plus 36. Simplifying one more time, putting this in standard forms, we have negative 39 plus 25i over 37. If those all reduce, we would then reduce them. These do not, and so that's our final answer. Keep in mind, you could also split this up even into real terms, so negative 39 over 37, and imaginary terms. This step is not required, but they do mean the same thing, so just be aware of that. Okay, so keep in mind, now that we have real and imaginary solutions, we can solve a quadratic without just writing no real solution. So factor, make sure it equals to 0. Square roots are good for 2 terms if you can just take the square root of both sides. Completing the square, make sure that you have c, your formula c is equal to b over 2 squared, and adding that to both sides. And then if you're using quadratic formula, make sure it equals 0. So all of the same methods of solving, but just keep in mind now you can have negative answers. So for example, if I have 4x squared plus 3, go ahead and solve this out, and then we'll talk about your answer. Okay, so subtracting 3, dividing by 4, and then taking the square root. This is where normally it would have been okay for you to just write no real solution. But we are going to, and don't forget your plus or minus, we're going to actually put plus or minus, and we have the square root of negative 3 over 2. And then we're going to simplify this further. So x equals plus or minus, and bring out your I. So anytime you have that negative underneath that radical, go ahead and bring out your I, and any numbers too that you can, and then leave that over 2. So we're going to write our answers this way from this point forward. And then do the same thing with this one. Use whichever method you want to solve it, but make sure you bring out the I. Okay, I plugged into quadratic formula real quick. You could also divide out the 4, then use completing the square, though personally I think that's a little bit tougher. Here again is where we would have typically just written no real solution. We're going to break this down instead. 48 breaks down into 16 and 3. Keeping in mind we're going to use a negative 16 here. And so this then simplifies. I'm going to come up here into 16 plus or minus 4i root 3. All over 8. These outside numbers all have something in common, so we can reduce this one more time by 4. So our final answer is x equals 4 plus or minus I root 3 all over 2. And so those are our complex roots for that quadratic. All right, and that is it for the lesson. Let me know if you have any questions, and have a great day.